The universe is vast and mysterious, filled with wonders that continue to baffle and amaze us. From the smallest subatomic particles to the largest galaxies, there is so much to explore and discover. And while we have come a long way in understanding the complexities of the cosmos, there are still many things that we don't know. But what if we could go back in time and witness the very beginning of everything? What was it like at the start of the universe? In this video, we will take a journey back in time to the beginning of the universe and explore the incredible events that took place in those first few moments. Join us as we uncover the secrets of the Big Bang and learn about the incredible forces that shaped our world. So let's get started. Let's start by talking about the Big Bang itself. According to the prevailing cosmological model, the universe began approximately 13.8 billion years ago with the Big Bang. At this time, all of the matter, energy, space, and time in the universe was compressed into an infinitely hot, dense point, known as a singularity. Suddenly, this singularity began to expand rapidly, giving rise to the universe as we know it. In the first few minutes after the Big Bang, the universe was a hot, dense soup of elementary particles such as quarks, electrons, and photons. As the universe expanded, these particles began to cool and combine to form more complex structures, such as protons and neutrons. As the universe continued to expand and cool, these protons and neutrons began to form atomic nuclei, which eventually captured electrons to form the first atoms, mostly hydrogen and helium. This process of particle formation and atomic nuclei formation continued for several 100,000 years. During this time, the universe was also filled with radiation, including light and other forms of electromagnetic radiation. As the universe expanded, this radiation became cooler and less energetic. Eventually, the universe had cooled enough for stars and galaxies to begin forming. This process of star and galaxy formation continued for billions of years, leading to the universe that we see today. One of the most incredible aspects of the Big Bang theory is the idea that all of the matter and energy in the universe was once compressed into a single point. This raises questions about what caused the Big Bang in the first place, and what existed before the universe began. Unfortunately, our current understanding of physics does not provide any answers to these questions. The Big Bang theory only describes what happened after the universe had already begun expanding. Another fascinating aspect of the Big Bang is the separation of the fundamental forces. In the first few moments after the Big Bang, all of the fundamental forces of nature were combined into a single force. As the universe expanded and cooled, these forces began to separate. Gravity, electromagnetism, and the nuclear forces are the three fundamental forces that we know today. It's not entirely clear how or why these forces separated, but it's believed to have been related to the formation of particles and the structure of matter. We know that gravity is the force that attracts any two objects with mass towards each other. It's what keeps our feet on the ground and what causes planets to orbit around stars. But gravity is a relatively weak force compared to the other fundamental forces. In the early universe, the conditions were so extreme that gravity was not strong enough to overcome the other forces. However, as the universe expanded and cooled, the particles began to move slower, and the distances between them increased. This allowed gravity to become the dominant force, causing matter to collapse and form stars and galaxies. Electromagnetism is the force that causes charged particles to attract or repel each other. It's what causes magnets to stick together, and what allows us to use electricity. It's in the early universe. The conditions were so hot and dense that the particles were moving extremely fast and were closely packed together. This made it difficult for electromagnetic forces to have a significant effect. However, as the universe expanded and cooled, the particles began to move slower, and the distances between them increased. This allowed electromagnetic forces to become more significant, leading to the formation of molecules and other structures. The nuclear forces are the forces that hold the nucleus of an atom together. They are incredibly strong forces, but they only act over very short distances. These forces cause protons and neutrons to combine and form the nuclei of atoms. Without these forces, the positively charged protons would repel each other, and the nuclei would fly apart. It's important to note that our understanding of the universe is constantly evolving, as we make new discoveries and develop new theories. What we know about the Big Bang and the formation of the universe is based on the best evidence we have at the moment. However, it's possible that future discoveries could lead to revisions or even a complete overhaul of our current understanding. Now let's talk about some of the evidence that supports the Big Bang Theory. One of the key pieces of evidence is the redshift of distant galaxies. When astronomers observe light from distant galaxies, they notice that the light is shifted towards the red end of the spectrum. This redshift indicates that the galaxies are moving away from us. Farther away the galaxy, the faster it is moving away from us. This observation led to the conclusion that the universe is expanding. The Big Bang Theory is the only cosmological model that can explain the observed expansion of the universe. Another piece of evidence is the cosmic microwave background radiation. In the 1960s, Arno Penzias and Robert Wilson discovered a faint microwave background radiation that is coming from all directions in the sky. This radiation is believed to be the afterglow of the Big Bang. It's an incredibly precise prediction of the Big Bang Theory and provides strong evidence for the model. Let's finish off by discussing the implications of the Big Bang Theory. The Big Bang Theory has had a profound impact on our understanding of the universe. It's revolutionized the way we think about the origins and evolution of the cosmos. The theory has also led to many technological advances, such as the development of new telescopes and instruments to study the universe. And it continues to inspire new discoveries and exploration. As we continue to explore the mysteries of the universe, the Big Bang Theory will continue to be a guiding light, helping us to unlock the secrets of the cosmos and our place within it. We've only just begun to scratch the surface of what's out there. So much more to discover and explore, and we can't wait to see what the future holds for our understanding of the universe. If you enjoyed this video, please leave a like and subscribe for more updates on all things space and science. Thank you for watching, and we'll see you next time.